Good morning to all of you. So today I am going to cover the first law of thermodynamics, which is in second unit. So in this case, certain things. Uh, First thing is, in the previous class we have discussed what is the significance of heat and work transfer relations, and what are the sign conventions of heat and work transfer. Then Joule has conducted the series of experiments to formulate the relation between heat and work interaction, and that's why we will call this one as the law of conservation of energy. So here we need to discuss the first law of thermodynamics and its corollaries. First law applied to a process, that is a constant temperature process, constant volume process, isothermal process, polytropic process, adiabatic process. So this is how you need to apply the first law of thermodynamics to the various process. Next, energy balance for a closed system, the specific heats, what is meant by internal energy, enthalpy, and the specific heats of solids, liquids, and gases. So this is the syllabus of the first law of thermodynamics. Now coming to this, after listening this particular video, the student is expected to learn the Joule's experiment. What are the corollaries of a first law of thermodynamics? He could understand the energy balance equation in first law of thermodynamics. So the first law of thermodynamics, where J.P. Joule has done the work in 1840 to 1849, carried out the series of experiments to investigate the equivalence of a Kelvin equivalence of work and heat. So in one of these experiments, Joule used an apparatus which is shown in the figure, So prior to Joule, heat is considered as invisible fluid flowing from a body of a higher calorie to a body of lower calorie, and this is known as the caloric theory of a heat. So he has taken one container which is insulated, and in that container, one pulley which is connected along with this paddle wheel. So paddle wheel along with the pulley. At the end of the pulley, some weights is also mentioned, and on the other side, the thermometer is kept by keeping some water inside the vessel. So how the equivalent of a work can be converted to the heat, so that particular information all it is given by this one. So that is here, once the work is converted to the heat and the heat will be converted to the work, a cycle is going to be established. So this particular law you can call it as a Joule's equivalent or a mechanical equivalent of a heat. So when heat is added to a system, it is positive. When heat is leaving from a system, it is negative. In the same way, work done by the system, it is positive. Work doing onto the system, it is negative. Say in case of refrigerators, air conditioners, and uh, heat pumps, you need to give some work input to transfer the heat from low temperature reservoir to the high temperature reservoir. Generally, always the heat flows from high body temperature to a low body temperature. But if you transfer the heat from low body temperature to the high body temperature, you need to spend some amount of a work. So, but before that one here, there is one video lecture, video which is provided here, which is going to show the first law of thermodynamics.
What a peace, what a silence.
कितनी गर्म
Hello friends, welcome back to our channel Physics and Animation. Today we will talk about the following topics. Number 1, Joule's experiment and first law of thermodynamics. Number 2, first law for a closed system undergoing a cycle. Number 3, first law for a closed system undergoing a change of state, a non-cyclic process. So let's start. Joule's experiment and first law of thermodynamics. James Joule. In 1844 to 1854, the English scientist J.P. Joule conducted experiments which were the first step in the quantitative analysis of thermodynamic system and which led to the first law of thermodynamics. Important elements of a Joule's experiment. In this experiment, J.P. Joule takes a closed system where there is not any interaction between system at temperature T1 and surrounding atmosphere at the same temperature T1 with the help of an adiabatic insulation. Therefore, heat energy is not going to cross the boundary of the system. Thermometer is used to calculate the change in temperature, paddle wheel, and pulleys carrying a load at the one end. Let's move forward and try to understand the Joule's experiment with the help of animation. Joule's experiment. In this experiment, as the weight W fell through a height Z, the amount of work done measured by the change in potential energy. Then work was done on the fluid by means of a paddle wheel. The work increases the vibrational energy of a fluid, which causes a rise in temperature T1 of a system to temperature T2. Let the insulation now be removed. Now the system at temperature T2 and the surrounding atmosphere at temperature T1 interact by heat transfer till the system return to the original temperature T1 by attaining the state of thermal equilibrium with the atmosphere. In this way, system is taken through a cycle. First law for a closed system undergoing a cycle. When work was done on the fluid by means of a paddle wheel, the work increases the vibrational energy of a fluid, which causes a rise in temperature T1 of a system to temperature T2. Let the insulation now be removed. Now the system at temperature T2 and the surrounding atmosphere at temperature T1 interact by heat transfer till the system returns to the original temperature T1 by attaining the state of thermal equilibrium with the atmosphere. In this way, system is taken through a cycle. Amount of heat rejected by the system to atmosphere could be easily determined by the equation dq is equal to mcp T2 minus T1. With this experiment, Joule found that the net work input W to the system was always proportional to the net heat Q transferred by the system to the atmosphere. Statement of a first law for a closed system undergoing a cycle. This law, based on the Joule's experiment, states that if a system executes a cycle transferring work and heat through its boundary, then the net work transfer is equivalent to the net heat transfer. Also, cyclic integral of dW is equal to J times of cyclic integral of dQ, where J is the Joule's equivalent. First law for a change of state or non-cyclic process. The expression net work done is equal to the net heat transfer applies only to systems undergoing cycles, and the algebraic summation of all energy transfer across system boundaries is zero. But what if a system undergoes a change of state or non-cyclic process during which both heat transfer and work transfer are involved? The net energy transfer will be stored or accumulated within the system. If Q is the amount of heat transferred from the system during the process, the net energy transfer Q minus W will be stored in the system. Energy stored is neither heat nor work and is given the name internal energy or simply the energy of the system. According to the first law, for a non-cyclic process, it states that all the heat energy given to a system is converted into internal energy and work done. Thanks for watching, friends. Please don't forget to like our video and subscribe our channel, and also press the bell icon so that you will be notified whenever we upload a new video.
So this is how the relation is developed. So finally, del Q minus del W is nothing but equal to du. So that is known as the closed system. That is in the internal energy which is stored in the system. So that is the first law of a thermodynamics. So the corollaries, what are the corollaries? Internal energy of the system remains constant, energy of an isolate system remains constant, and perpetual motion machine of the first kind is not possible. So internal energy of the system is nothing but it is a property of a system. So these are the various corollaries of a first law of a thermodynamics. Thank you, one and all. Hope you have got the first law of a thermodynamics concept. Thank you.